the cloud. Okay, recording.
Good evening, everybody. This is Emily, and I am excited to do Tree ID with you virtually. And I'm excited because I haven't done it this way before, but it should be entertaining because I like to do a lot of running around when I'm in the classroom, and I have to stay seated tonight. So this will be an interesting exercise for me as well. So we'll get right into it and start off with me learning how to advance my slides. So I'm an inquiring mind, and I want to know, why do we need to know how to ID trees? And I think it's really basic when it comes down to it. We want to be able to communicate with one another about trees. We want to be able to tell each other things about trees. And we want to make the right decision about the type of tree that we want to plant in our yard, in our park, near the water, depending where it might be. There's different things we have to consider. And I know that the tree stewards often have another program that they call Right Tree, Right Place. And I'll let that go for another time because I probably can't speak to it tonight. We're gonna basically be focusing on IDing trees and not where they should be located. But sometimes I'll mention where a tree likes to be, and hopefully that will help you guys as well. And oops, my computer. Sorry about that. Okay, so I have to advance my slides, and sometimes I can't see. There we go. So scientific names. The first thing we want to do is we want to all be on the same page talking about trees the same way. Trees have common names as well as scientific names. And the scientific name is a binomial nomenclature. And that's made up of two pieces. That's the genus, which is the noun, and then the specific epithet, which is usually an adjective of some sort. And that adjective describes geographic range, sometimes habitat, the part of the plant, or it can honor the person that found the plant. So in this case, we have Quercus rubra here, and that's for red oak. And those oaks tend to have something red on them from time to time. So I think that's, and that was named by Linnaeus, that has the L after it. And the writing of that name down there is how you would see it in the literature, and that's actually the full name for the plant. And we also want to mention, while we're talking about scientific names, traditionally all plants are classified and categorized by their flowering parts and their reproductive structures. We're going to be talking about leaves tonight, so I'm going to have taken the deck and reshuffled it, so it's going to be not primarily about how their flower parts are arranged, because we're looking at leaves because we're out in the summer and we actually don't have any flowers at this point, not for the moment anyway. I'm having some struggles with my, there we go. Okay, so here we are on our next slide. I want to make sure that we get ready to go out with the right ideas and thoughts in mind. When I go out in the field, it's all about making sure I have the right tools to go with me. So things to have with you are a good tree ID book. I really strongly recommend the Common Native Trees of Virginia. They just released a new publication, and I've got that link on the bottom of this page because it was released in 2020. And I don't know if anybody knew that because we've all been dealing with our stay-at-home situation, but you can download it for free from the Virginia Department of Forestry website, or you can order it by mail to get a paper copy, and it's usually a really nominal fee. So a field guide's important, a ruler of some sort, binoculars if you're looking at leaves that are at the top of a tree and not the ones that are at eye level, and then a hand lens. Hand lenses are really helpful and very important. And since there is a little video of me in the corner, I'm going to do a demo. In order for a hand lens to actually work, you have to get it all the way up to your eye and bring in the object until you can actually see it. So that's really close to me. I have a lot of people when I teach, they'll be like, oh, that's really pretty. I know that they didn't see anything because they weren't looking and they didn't have the plant in the right location and their hand lens was too far away. So don't let me catch you doing that, because that's a big no-no. When you're out, you want to make sure you're using your observation skills, how to observe, what to observe, and you want to use all your senses: sight, smell, touch. Those are all really important pieces. I don't often advocate for tasting, because I don't know if that's a good thing to do, especially if you happen to like to try mushrooms. Doesn't always end well, especially for mycologists, so be careful. And I like to use something called multiple lines of evidence. So I might see the leaf, but I also like to verify that by looking at the bark or the fruit or the flower, other pieces of the tree as well, and where I'm standing, because those all will give me hints of whether or not I've got the right ID for a plant. And things you should be aware of. Everybody has a different way of learning. My mother has a photographic memory. I do not. So I have to write everything down and make sure that you learn how to do tree ID the way it works for you, instead of having anybody tell you how to do it, because that's not going to be always the best idea. And I really am struggling getting my slides to advance. Okay. Why do we use a dichotomous key to identify trees? Dichotomous means having two equal parts. So the key is a tool used to identify organisms, and it can be used for any organisms, or even how to, I think sometimes we use them for decisions with flowcharts. The dichotomous key provides a series of choices. Usually there's two. They're known as a couplet, and you want to read the entire couplet before making a decision. So not just reading the first part of the couplet, but the second one as well, because that'll help you ultimately get to the right name for the tree. And we're going to try and use the dichotomous key that is in the Common Native Trees of Virginia, so that it becomes a little bit comfortable to you, and you'll get the idea of what a dichotomous key is as well. There we go. So before we get started on this, we actually need to figure out what is a tree. If you go outside and pick out the thing that has a 1-inch DBH, which is diameter at breast height, you're gonna have a really hard time distinguishing it between a tree or a shrub, because shrubs can be multi-stemmed and have very small diameter at breast height circumferences. And you want to make sure that when you are going to identify a tree, that you are choosing a tree that you're going to be successful identifying. So I always suggest that you should be able to get under a tree and be able to walk around it in order for you to think about whether or not you want to identify it. If you get to a tree and you can't walk around it and you have to duck to get underneath it, you might want to look for a different tree to identify. Don't use that one to impress your friends with. Try a different one where you have lots of different pieces. Something that's that young, that's only got a 2-inch DBH, you're not going to have bark characteristics that are going to help you with tree ID. And you're going to make yourself, or you're just going to make it a little bit more challenging. So keep that in mind. You want to find something that's at least 15 to 20 feet high. It has a trunk. You want it to be at least 3, 5 would be great for the diameter of breast height, because we don't want you to get stuck in shrubland. Shrubs and trees, very different. And the nice thing is that the Virginia Department of Forestry also has a Native Shrubs of Virginia book, but that's a completely different talk. And if that's the one you wanted to sign up for, I don't know where that's being offered, so you'll have to go check. But that's an important part. We want to make sure that we look for the right item to start IDing with. And then we should go on to what the parts of the tree are. Trees have lots of different pieces. We start with roots at the bottom. There's a general trunk, which is the main trunk. There should be branches off of that with foliage and leaves. And I wanted to show this little chart on the side. Only 5% of the parts of the tree are leaves. So we have to keep that in mind when we do tree ID, because while we're doing the leaf tree ID, because it's summer and the leaves are there, there's a lot of times of year when you don't actually have leaves to help you with tree ID. And there's lots of different options. There's winter tree ID, there's spring tree ID, there's fall tree ID. And I happen to sometimes be tapped into to teach some of those too. So keep an eye out, and I always love going out and helping people to understand. But see in this percentages, 15% is for bark, or is for branches, stems, and buds. 60% is for trunk, and then 20% is roots. I've never taken a root ID class. I'm not sure I want to, but I have seen several tip ups, so maybe I should start thinking about that. It'll be a way to expand my repertoire in the future. Since we're talking about leaves and we're going to focus on leaves tonight, what are the functions of leaves? I usually ask people these questions, so since I can't ask you guys tonight.
Is the 5% by weight?
The 5%, sorry, from the last slide, is by how much of the tree, not by weight. But that was a good question. So back to leaf purposes. The main function of a leaf on a tree is to facilitate photosynthesis. The great thing that are byproducts of that is they also offer us shade, they reduce wind force, they keep it cooler, they filter out dust and other particles, and they also can help in a rainstorm by allowing you to sort of hide underneath them and not get as many raindrops on them. But watch out for those trees that have acuminate tips. Those are pointy tips that allow water to drain off into a drip tip and fall onto you. But you should also remember, now that we've passed the longest day of the year, photosynthesis is winding down in leaves, and the tree is going to benefit by not having to worry about leaves. So leaves are going to start looking ratty this time of year. Don't worry, don't fret. Trees are not in trouble or on the decline or going to have a problem because of drought conditions. Most of the time at this point, the tree itself isn't going to put any energy into trying to save leaves or ward off predation from insects and caterpillars and things like that. So they're okay with the leaves being eaten because they've done the most of their work at this point. And if you've been walking around outside, you'll see that we've already started getting some red leaves on some of our trees. So the early signs of fall are out there. Okay, leaf types. And here we go with our common native trees of Virginia tree identification guide. So one of the first things you'll see in that tree ID key is leaves. Are they needle or scale-like? Then go to 2. Or B, are the leaves broad and flat? Then you'd go to 14. So here in A, I've shown you a picture of what we're talking about for needles or scale-like. And we're talking in most cases about gymnosperms there, which is Greek for naked seed. And those usually are pine cone bearing plants. Ginkgo's in there too, because that's also considered a pine cone bearing. And then the other side of it is B over here with the broadleaf, broader flat leaves, and it's generally referred to angiosperms from the Greek for covered seed. So those are all of our flowering plants when we talk about angiosperms. Gymnosperms don't tend to have a flower, and that's where we get the cone bearing part of them, whereas angiosperms, we have gotten into flower production And that's why we have a covered seed from them. We're gonna just quickly go through a couple of those needle or scale-like in number 2, following the steps of the key. And then we'll get back to those broadly for angiosperms, because I think that's gonna be the place for people who have the most questions associated with tree ID. Oops, I went the wrong way. Now that I'm getting better at figuring out how to do this. So conifers, this is a leaf type comparison. We have things that could be scale or all like, that tends to be an eastern red cedar. And then we have things that are blunt and flat. Those tend to be things like a spruce or a fir. And then we have things that have needles. We're gonna stick to the needle track today. So for our tree identification here, number 2, needles at least 1 inch long, go to number 3, or needles less than 1 inch long or scale-like, go to 10. So blunt and flat and scale and all-like would all end up being number 10, and needles at least 1 inch long, you'd be going to 3, and we're gonna look at some needles. So conifers, it's really important to know how many needles are in each bundle, and that's how we can ID these for everybody. And then this is a quick and dirty cheat sheet here. If you've got a white pine, it's 5 needles per bundle, and that's, it helps you out on this one, because how do you spell white? W-H-I-T-E. So you know that you've got 5 needles that should be in that bundle. Virginia pine is 2, so VA, for those that are looking at the video, is Virginia pine. It's usually 2 and twisted. And then the pine cones are about 2 inches long. And Virginia pine is kind of a messy pine. It'll hold on to dead cones and dead branches as well. Pitch pine is a longer needle, and they're usually in bundles of 3. And then we talked earlier about the flattened eastern red cedar. And you can move my picture, I've heard, if I can find my mouse. If you're having problems seeing because I'm in that corner. And I'm gonna see if I can move myself. While we're doing that, does anybody have any questions?
Just that Lane loves the mnemonics.
And I can't seem to get my chat, or, oh, there's, okay, moving me over, so hopefully I'm in a better spot. Hopefully I don't, can you guys see me moving myself or no? Oh, well, you guys can move me wherever you want in the box, anywhere on the screen. Sorry.
Emily, there aren't any questions in the chat.
Okay.
Would you prefer that people use the chat box or unmute themselves and ask you directly?
We could do either way. I'm pretty open, and because this is the end of the conifer piece, I thought this would be a good time to have people take a moment if they had a question about them for me to answer those. And since I haven't heard any, I will carry on. So the next piece is we want to talk about, we're going back to the angiosperms, the broadleaf trees, and we want to talk about branching patterns. And from the common native trees of Virginia, number 14 is A, our leaves opposite, go to 15, or B, our leaves alternate, go to 25. So we're going to follow the A piece for a moment, and you should see in these diagrams, these pictures, we have the one on the left is alternate branching. You can see the buds on alternate sides of the branch as they go up, whereas the picture on the right, just like I have one shoulder on this side, I have another shoulder on the other side, those are opposites. So opposite and then alternate would be sort of like a walk like an Egyptian move, but I can't do that since it's not easy to do that sitting, nor can you probably see it. So we're going to continue on. If you have questions, this is going to be a pretty important piece for dividing trees. One of the first things you should do when you are identifying trees is take a look to see if things are predominantly opposite or predominantly alternate. And I say predominantly because you have to remember that in nature, things don't always go according to plan. Our opposite tree could lose a branch and start looking alternate. But an alternate can never really fool us and pretend to be opposite. So that's why you want to see a predominance of opposites. And when you look at those trees to identify them from branching pattern, start at the outer edges of the tree and sort of work your way in. If you look at the older parts of the tree or the main trunk stem, you may have lost that opposite piece as it grew older and things like that. So start from the outer edges and work your way in rather than looking from inside out of a tree when you're trying to look for that. That may have sounded really bizarre, but hopefully it works.
Keith is asking, other conifers like arborvitae are multiple branching always opposite?
So conifers don't usually follow this law, these branching pattern pieces. This is going to be just an angiosperm broadleaf piece because if you think about a white pine, that has a whorled branching pattern. And that's really an interesting piece on the white pine because you can count the whorls and get the age of the tree. And those whorls, almost if you were to turn them, take them from the flat whorl that they are and turn them around, it would almost look like a bicycle wheel with all the spokes of branches coming out on a white pine. But arborvitae is a little bit different. It's not a native, so I'd have to look closer at that, and that has more of that all shape branching scaly pattern rather than a branching pattern that I would assume more specifically with angiosperms or broadleaf trees. I hope that helps. So the next thing when we are doing our key from the Virginia guide is, are the leaves compound or simple? And we're gonna take the compound trek first because that's number 16, and then we'll flip back and we'll go to the simple leaf trek. And I want to point out we've got the diagram of the simple leaf versus the compound leaf, and you see the mark where it says that it has an axillary bud. Where that bud is, you'll also notice that the petiole, which is the little attachment from the leaf to the stem, it gets sort of widened or swollen at the base. So when you're out in the woods and you're trying to figure out if you have a compound leaf or a simple leaf, you want to follow the petiole until you find that swollen nodule before you get to the axillary bud. Or if you see the axillary bud, that'll tell you too, because you want to be able to figure out if you're looking at a leaf or a leaflet. And you don't want to get yourself sideways by looking at a compound leaf that has opposite leaflets and you think you're in the opposite branching pattern when you're really in an alternate branching pattern, but you've misidentified what the leaf is versus what the leaflet versus the leaf is. And you'll see more examples of that as we go. So we're doing compound leaves and we're doing opposite compound leaves, just to remember our trek as we're going through the key. So here leaves are pinnately compound, and I've inserted a diagram to show pinnately compound versus pinnately compound, palmately compound versus pinnately compound. Palmately compound is easy because it's like the palm of your hand, and we only have one, so that's the yellow buckeye, and I've got the picture of it here. And that's your palmately compound leaf. So each of those there's 5 leaflets on this one. It doesn't always have to be 5 for a palmately compound. I don't think they figured out how many digits we have, and then therefore they've replicated that in nature. The other option is the pinnately compound, and that's where they are side by side instead of using, so it's more like a branch that goes out with them on either side. So this is our only palmately compound opposite branching tree, the horse chestnut or yellow buckeye. And if you are an Ohio State fan, you should be well aware of your branching pattern for the buckeyes. Your other compound leaf associated with opposites is going to be a pinnately compound leaf, and that's going to be found in the olive family. Here I have the green ash, which is Fraxinus pennsylvanica, and the white ash, Fraxinus americana. And the good news is, because they're opposite branching and it's pinnately compound, you already know that you've got an ash. The bad news is it's really hard to tell these two apart when you just have vegetation. Some hints I have on this slide for you is the green ash. You can see that I followed that by the letter D. That D is the shape of the leaf scar that you should see on the branch or twig when the leaf is pulled off. And you see the U next to the white ash. So that should be the same shape of the leaf scar. The leaf scar should be a U when you pull off the white ash leaf. And no offense to anybody, I don't know where everybody's from, but they usually talk about stern Pennsylvanians for the green ash and happy Americans for the white ash. But to be completely honest, when I'm out in the woods, I really often just use where am I versus what does this leaf scar look like associated with an ash, because it often depends of where I find this tree. A white ash does not like to be in a wet area. It likes to be at the top of a hill, top of a mountain, anywhere where it is nice and dry. Green ash loves to be in low-lying, wet, swampy areas. So if I am headed down a slope and I'm not very far from a stream, I would often assume that I'm in green ash land. Whereas if I'm on a southern west-facing slope and I see an ash tree, usually west-facing slopes are drier than north-facing slopes. I will tend to think I am seeing a white ash. And then to really solidify it, if you are dutiful and you go to check this tree year round, you want to look for fruit. The big tell is between the two fruits, and these are samaras. The green ash samara has a very thin needle-like seed in the samara, which I think you can see in the picture below the green ash, whereas the white ash has a pretty fat and robust seed at the very bottom of the samara, whereas the green ash, the samara actually surrounds there's wing material for the seed surrounding that seed. And then the numbers in brackets are the number of leaflets that you can see per compound leaf. So for the green ash, they say it can be anywhere from 5 to 11. For white ash, it can be 5 to 9 leaflets, but most often it's 7. And of course, the one that I took a picture of has 9. So I actually had to look up the number of leaflets for these in order to give this presentation, because I most often do not use the number of leaflets in a compound leaf for the ash to identify it. So hopefully I've given you enough tips and tricks that you'll be able to be well on your way when you're out there. So we're gonna swing back, and we're going back to those opposite leaves, and they're not lobed, which is where we're gonna go first, and then we're gonna go to opposite leaves that are lobed. And I've got another diagram here of leaves. As you can see, lobes are pieces that stick out. And then on the other side of that diagram, something you should be very keenly aware of is sinuses are the names of the spaces between the lobes. Yes, in botany, we have named blank space. So it's important to recognize that and keep that in mind when you're reading a tree key, because that might get you turned upside down otherwise. So we're going with leaves that are lobed, that are not lobed, that are opposite. And our first one and our only one is the dogwood. And that's Cornus florida. And the key is it's about 6 inches long, edges not lobed or toothed, bark is usually blocky, and then if it's larger than that, then you've got the invasive Paulownia. So that's what it has in the key. And then I couldn't help myself, I had to put a picture of it in flower too, because it can be so gorgeous. And remember, the white are bracts, and then the flowers are in the center of that because it's a composite flower. It has multiple flowers in the middle and the 4 white bracts surround it. So that's our entire leaf for opposite branching. And I tried to give you a picture of the opposite branching in the corner, where you can see 1 leaf on one side and 1 leaf on the other coming out of the stem. Maples are our other compound leaf, or sorry, our other opposite branching group. And I had a lot of fun recently because I decided to go out and find as many maples as I could. And you can see from my pictures that I'm missing one. So the box elder was elusive to me, unfortunately, but I have put in there how many leaflets it has, 3 to 7, and I've even put in a diagram of it, a drawing. And I've even heard people tell me that box elder, you can pull it together with all of its leaflets and make one giant maple leaf. I think that's very arts and craftsy, and I'm not good at that. So I'll leave that to other people to do. So to go through these pictures, the striped maple is the one at the very top of here. It looks like a duck's foot, that leaf, or at least it does for me. Sugar maple is going to be right underneath the striped maple leaf, and sugar is spelled S-U-G-A-R. And there's always, it's usually, this leaf has been eaten a little bit, but it usually has, it's an entire margin. It's not toothed at all. And it usually has a U for that sinus. So there's a U on both sides of that one. And I think that's pretty evident on that sugar maple. To the right of that is the Norway maple. And you can see how much broader that leaf is. There's much more green for photosynthesis going on. And those leaves on that tree will all turn yellow and all drop off at the same time. Whereas your sugar maple will have that beautiful yellow to orange to peach to red coloration in the fall. Below the sugar maple leaf is going to be a red maple leaf, and red maple leaves are always very easy to tell because they have the serrated edge all the way around them. And then right next to that is the silver maple, and that is going to be the one that has the deep, deep sinuses of all of these, and also has a bit of a toothed edge. I wouldn't call it serrated, but it is got some toothing on it. And hopefully that helps. So I'm going to switch to my last slide. So I've done this a little bit differently. So we went through all of the plants, are all the trees, and now we're looking at the acronym. It's Madcap Horse. Maples, ashes, and dogwoods are all going to be in your opposite camp. Caprifoliaceae has now changed to Adoxaceae. And that includes viburnums and elderberry and honeysuckle, and then horse is for the horse chestnut and the buckeye that are on the bottom.
So the question is, the Norway maple native?
The Norway maple is not native, which is why it had an asterisk next to it on this screen. So now that we have finished all of the opposites, we're going to go into the alternate realm. And hopefully I will have done this in a way that everybody will understand, or at least you'll get insight to how I think. So I'm going to go back and show you that branching pattern slide one more time, because we're going to take that 14B trek for leaves alternate. And this is where we have that branch right underneath that letter B and that name for it. And we're going to start heading to look at things that are coming out in a juxtaposition in that way. So we're going to go back to leaf characteristics. We want to talk about those simple leaves and those compound leaves. And amazingly enough, in the book, it actually goes through compounds versus simple. I'm going to switch it up here. I'm sort of deviating away from the dichotomous key that is in the Common Trees of Virginia, because I wanted to make this as easy as possible. So we're going to do simple leaves first, and we're going to do it a little differently, and I'm going to show you how. So I want to do it by leaf characteristics and leaf margins. I know I'm always trying to do something just a little bit different. So I want you to take a second to look at this. We have leaf margins. I'm trying not to use all of those words, but we're going to be talking about lobed leaves. We're going to talk about serrate leaves. We're going to talk about doubly serrate leaves. Cerulate is with fine serration, so you'll see that word as well. I don't think I've got any ciliate or sinuate. I might have some spiny and some undulating. But leaf margins are really helpful when we're talking about leaves. So I would keep that in mind as we move forward. And I'd also like to point out some of these leaf shapes. So a heart-shaped leaf. Everybody's pretty familiar with the redbud. It has a classic heart-shaped leaf. Things with an oblique base, we're going to look at some of those because I think they're very interesting, and they can really quickly be identified just by noticing that the base of the leaf doesn't come in with the same shape on both sides. Then we have linear leaves, triangular leaves, ovate leaves, lanceolate leaves, rounded leaves, truncate leaves. We should be able to find an example of that. And then venation is another piece. We're going to talk a little bit about pinnate venation. And I think it's articulate venation, the one in the bottom left-hand corner. That one you already saw, and that was demonstrated on the dogwood. The dogwood leaf has that type of venation. So along with doing it by leaf characteristics, I'm going to do it by family too. So I really wanted to see how easy this might be, and I look forward to your feedback. So first we're going to start with the elm family. And I have common hackberry, American elm, and I've stuck underneath here Tiliaceae, which is the basswood, because I want to mention that one too. And in the bottom corner, I've put in oblique bases. So all of these leaves, in my mind, don't have bases of the leaf that come together the same way. They're not a mirror image of one another. So on the right top corner where the walking stick is, that's the hackberry leaf, and you can see one side is sort of cut off while the other side is a much more robust and fatter side on the right or the left side of that midrib where the walking stick is. The elm leaf, which is underneath the elm word, that has really nice pinnate venation on it, but it also has that oblique base at the top where right before the leaf touches to the tree. And then another one that I see this in is the basswood, which is Tilia americana, and that's the bottom right picture. It's not always really good at this, especially since there's a Tilia cordata, and they can be a little bit transposed a little bit. So sometimes I see the oblique base, and sometimes I don't. The cordata definitely doesn't have it. But I think right now, when you're out in the woods looking at a tilia, you should see a really funny, weird, leafy appendage coming down that has a stem coming out of it that will have fruit that's developing on it. And that's the fruit. It's way weird, but really cool if you're a geek about trees like I am. All right. So I'm going to go on to the next family, and we'll see how this, see if there's any questions from the...
Brahmana is asking, is the swamp oak leaf margin sinuate?
So is that swamp chestnut or swamp white? She's going to have to let us know. Okay. So the next family is the birch family. And this one I've put in the right bottom corner. This has doubly serrate, serrate, and cerulate leaf margins. So the first one in the top of the screen is the river birch, and you can see that doubly serrate leaf margin on that one. Next to that going down is going to be the sweet or black birch. And I love this picture because it also shows the little tiny spur shoots that I think I see when I look at a black birch in the woods. I don't think I think this is more of a serrate edge than a doubly serrate leaf edge. Below that is the American hornbeam or musclewood, which is the carpinus. That has a doubly serrate leaf, as well as Australia, which is hornbeam, which is right next to it. And I actually have the fruit on top of the leaf. Go Emily's photography skills. And then in the bottom, we have the smooth alder that's showing great pinnate venation. And I would say that has cerulate leaf margins. It's not the best picture, but if we got really close to it, we'd see some really fine toothing on there. For those that haven't had a class with me before, carpinus, the American hornbeam, also has the common name of musclewood or ironwood. And I often say I want to carpe diem, seize the day, and my huge flex bicep muscle here reminds me that I'm in the carpinus because it's carpe diem. I don't know how well that translates if you can't see the picture of me, but there you go. So those are the birches, and they always are going to have some sort of serrate edge of leaf margin, at least for the ones that we are looking at here today. Then we switch over to the magnolia family, and all of these are going to have entire leaf margins. I don't ever come across a magnolia that has some sort of a toothed or dentate, or it's always a nice smooth edge on these unless they've been chomped on by somebody. And here we have the tulip tree is in this family. And that has that truncate apex for its leaf. Sometimes in a pinch for Halloween, you can use that as your cat mask for your little one. Next to that is a sweet bay magnolia. I wasn't able to get the leaf in its entirety, but that was the sweet bay that was in my yard that was blooming that day. The southern magnolia has that really firm evergreen leaf that's really shiny on top and has that rusty orange hairs on the bottom. And then cucumber magnolia is the leaf that's next to that. It's usually found in the mountains more than down in the valley, but it is an interesting flower when you happen to walk underneath it. I also find it in rocky sort of drainages too. I find it in the strangest places. And then finally, the last one is big leaf magnolia. There's one of these nearby, and that's a 15-inch centimeter, or the 15-inch ruler, sorry, next to that leaf to give you a scale of how big it is. And the Latin here is Magnolia macrophylla. So that's really big leaf in Latin. So I think that helps when we're looking at these things. And obviously the southern magnolia is grandiflora, and that's because of that huge flower they have. Magnolias evolutionarily are one of the very first flowering families. So we went from wind pollination, where things are dumping pollen in the air in the hopes that something catches it in our pines, as well as I think our birches start off that way too, using wind pollination. But here in the magnolias, we've decided that we're going to attract an insect in order to have pollination occur. And so these flowers are really big, really showy, have lots of everything. Lots of petals, lots of stamens, lots of anthers, lots of filaments, lots of carpels. It's just a mayhem of lots of exciting stuff in order for reproduction to potentially be successful. And clearly they have been successful. We see tulip trees all over the landscape these days. Beautiful family, really cool in the evolutionary chain of things too. Okay. We're gonna go on to the rose family. There's only two here that we were going to talk about because we don't have many of these that are native. So the first one is the black cherry, which is the top picture. And then the lower picture is the serviceberry, amelanchier. Both of these have finely toothed leaf margins. And I think I need to work a little bit more on my picture taking to get those to show up a little bit better. Amelanchier, the serviceberry, is one of those first ones that blooms in the spring. And it's called serviceberry because it was an indication to the clergy that it was time to go into the hollers and bring out those people that we could now dig a grave for. So I think that comes from a very long stead background. And that's the rose family. And I'm gonna move on to the beech family. So we're getting close to the end of the simple leaves now that we've gotten to the beech family. So this is the Fagaceae family, and the family is traditionally for Fagus grandiflora, which is the American beech. And I have a leaf of that right in the right-hand corner. That's got a beautiful pinnate venation. The American beech is that one with the really smooth bark that people like to carve their initials into. It's also the one when you're doing winter botany or drive-by botany. I don't know if I should tell people that I do this, but at 55 miles an hour, you can identify this tree in winter because these leaves, they curl up and turn beige in the winter, and they sometimes stay attached to the tree because they're marcescent, which means that the leaf doesn't fully do abscission, so for the leaf drop at the end of the fall season. So you can see these beige leaves as you're driving at 55 miles an hour, and you can identify it correctly as the American beech. The other one in this family is also the American chestnut, and that has a serrate leaf margin or a dentate leaf margin, depending on how you would like to classify it. Obviously, these aren't really seen much in the wild anymore or much in a large tree form anymore. These are mostly relegated to the bottom of the forest floor because they were devastated by the chestnut blight. But their roots live on, and they are assisted by other roots of other trees, and they continue to put out root sprouts and it's kind of fun to find one. I know that I found one with a bunch of the tree stewards when we were down in Barcroft Park. Especially as they get a little bit bigger, it can be a little bit bittersweet because you can start to see the chestnut blight impacting the bottom of the bark of the tree. But if we're in the beeches and we're talking about, and then we're in this family, we quickly slip over into the oak because the oaks are part of the Fagaceae family. And I really want to help people get a little bit more of a handle on the white oak group versus the red oak group. So white oaks have lobes, whereas red oaks have bristle tips. White oaks tend to have light gray bark. Red oaks tend to have bark that's dark gray. The acorns on a white oak take about a year to mature. They take 2 years to mature on a red oak. And the inner shell of an acorn is smooth for a white oak, whereas the inner shell for an acorn for a red oak is hairy. Now, you should be forewarned, oaks are a nuisance and they're promiscuous, so watch out. They don't always do things the way they're supposed to. But the good news is that the white oaks are promiscuous with the white oaks and the red oaks are promiscuous with the red oaks. So you shouldn't have to worry about like a northern red chestnut, like not gonna happen, because that's a white and a red squished together and they don't do that. So we're gonna go to the white side or the white group side, and I've got 3 examples of them here. Here is the white oak in the right corner, top right corner. We have the chestnut oak in the bottom corner, and you can see the chestnut oak is reminiscent of the chestnut leaf, which is why it has the name chestnut oak as its common name. And then we have the post oak, and that's really easy to identify because it has this clear, almost cross-like look to the leaf, and that's the way they look. And our question earlier was about the swamp oaks, and I think that was either a swamp white, which is Quercus bicolor, or a swamp chestnut, and I actually have to look up the Latin for that one because it's not on the top of my tongue, or the tip of my tongue. But I would say you are looking more at lobed leaves when you're talking about white oak, so swamp white as well as white oak. When you're talking about a chestnut oak, you're looking more at like a dentate. Actually, I should just look at a picture and make sure I get this right. I think I have a picture nearby. There we go. I would say we have more of a crenate look for our chestnut oak. And something even more pronounced than that when I'd go back to maybe lobes for a swamp chestnut oak, because the swamp chestnut oak is usually more lobed than the chestnut oak. And sorry, I don't have a diagram of that here for you today. So going on to the red oak group, or red or black, sometimes they call it the black group. They're interchangeable to me, so I try not to have a favorite, one or the other. Red comes more naturally because there's a couple of red oak names. So I've tried to order these in the pictures in order of how the names are on the slide. So the northern red oak is the one in the top, or the one picture in from the right-hand corner. This is a really good test of my right and left abilities. And you can see that red sort of stem in the middle coming up that has the leaves on it. So this is where we want to make sure we're really careful about oaks. When you look at an oak leaf, depending where you are looking at that leaf on that tree depends on what it looks like. So I could see this northern red leaf oak at the bottom of a pin oak, or even on a scarlet oak or a southern red oak, because at that low level on a tree, it's in the shade and it's doing everything in its power to get sun. doesn't really care what the leaf shape needs to look like. It's only when you get to the middle of the tree or even the top of the tree when you start seeing the true leaves for that tree or that oak. So that's the word of warning. Take it for what it's worth. As I said, oaks can be a little conniving. So we have the northern red oak leaf, and next to that in the very corner is the black oak leaf. When you are picking up paper at a paper store, yeah, I think we all use like 20-pound paper for our printers. I think of the black oak leaf as more like a 50-pound paper. It's usually a thicker, tougher, hardier leaf that'll last longer. It's usually that, as well as the southern red, tend to be the ones I end up breaking the most leaves from. The southern red oak, this falcata, is the one that's in the middle here, and it's got that long, thin neck on the southern red oak. And when I used to find southern red oaks, I used to also find turkeys, wild turkeys. So I always think of this being some sort of like a turkey foot leaf. But be careful, if you get further south than us, there is a turkey oak, and the leaf doesn't quite look like this. So be careful of my memory skills when you venture further from Virginia and into the Carolinas. Next to that is the scarlet oak. And below that is the pin oak in the corner. And it's really important when you look at a pin oak, there's usually wide open sinuses, big, fat, wide U's, whereas with a scarlet oak, and we're talking about the sinus, so this is the part of the leaf that is not there. So the space between the lobes almost curls back, and it looks like a C or an O for Scarlet O'Hara. And that's how you know you've got a scarlet oak. And that cocina means it turns red. So that's why it has that brilliant scarlet red color in the fall. That's really interesting to see and beautiful to see. Scarlet oaks in the wild are pretty bad self-pruners, so they usually look pretty scruffy. And another thing to know for when you're IDing trees, that pin oak, it has a very distinctive form when it's out, and it's not put on the side of a parking lot. Its lower branches really want to point down at the ground, and then its middle branches want to point out, and then its top branches want to point up. And what we've done is we've used it as a street tree, and we've planted it all over the place. And then we've been really smart, and we've gone around and we've cut off those lower branches that point to the ground so that we can fit our car underneath them. But then what happens is the branches above start curling down. So for those that are dealing with an oak where the branches keep coming back down towards them, you've got a pin oak that doesn't like you pruning it the way you are. And then finally, also in the red oak group is the willow oak. And the reason why it's called willow oak is it looks like a willow leaf, a little bit like a big fat willow leaf, but it's still a willow shaped leaf. And that one is in the red group because it still has a bristle tip at the very end of it. So those are the oaks. Oh, I have questions?
Yes. Marilyn would like to know if that's unique to oaks, that where on the tree you find the leaf affects the shape.
So the where on the tree you find the leaf and the shape is most specific to oaks because of the fact that these oak leaves are so distinctive with lobes and sinuses. So the cuts of the leaves change depending where they are found on the tree. Whereas when we looked at the magnolia leaf, that leaf is the same usually from top to bottom. It might be smaller at the top and larger at the bottom, but this leaf lobes and sinuses aren't there. It's just the same shaped leaf, just in different sizes up and down the tree. So so I would say it's more specific to the oaks rather than something you'd see across. Like you don't see really big fat red maple leaves at the bottom versus really skinny baby maple leaves at the top with different points. So I think that might answer your question. By the way, the Canadian flag is a mixture of a red and a sugar maple, just so you know. Bad trivia, I know.
And Keith would like to know, do all of the red oak group hold their leaves through winter?
So the red oak group can be known to hold some leaves through winter. The white oak is known to hold at least one or two. The red oak holds more, but I think that the last couple of years we've just had a really weird end to fall, and our oaks haven't been fully doing leaf drop at the end of the abscission. And remember, they're related to the beech, and the beech doesn't drop its leaves or remember to drop its leaves. So this whole family is supposed to be considered a more tropical group that has made its way biogeographically. It's trekking from the centers, or these more temperate areas, into areas where it's cold in winter, and to hold its leaves during winter is really a death sentence, because all of your leaf cells are going to explode when they freeze, because water expands when it freezes. So the trend for this family is to sometimes by mistake hold its leaves. Oaks are better than beeches at dropping their leaves. I think only in the last couple of years I've noticed the black oaks or the red oaks being a little bit worse at it, but I think that's just some funny ends of fall the last couple of years. I'm gonna go on because I think we now switch to compounds for alternate branching, and then I think we get to the end. So you guys have done a great job of hanging in there, and then we'll be open for more questions. Oh, I forgot, I had some extras because I really couldn't leave them alone. So the laurel family is Laurelaceae, and I have sassafras, which has the 3 different leaf forms that you've got: the mitt, the trident, and the entire leaf, all with an entire edge. And then we've got the northern spice bush that's in the same family. That's the shiny leaf on the red, on the right hand on the top. And remember, your laurels, they tend to have a fragrance. So both of these plants, if you crush the leaf or scratch the stem, they smell really good. Some people are lemony pledgy, some think a little bit else. I'll let you make your own determination. The next one is Tupelo or Nyssa. That's the black gum, Nyssa sylvatica. That's the tree that it looks like a giant has walked through the woods and stomped just on black gums to get across the forest. I know, I have a wild imagination. It also has branches that come out at like 90-degree angles, and I always suggest that it has a bit of an attitude because it has a hip swing when it grows up. Doesn't ever grow straight, and I don't know why. So I think it has some attitude. And then the last one on this is the American sycamore, Plantus occidentalis, and that leaf is in the bottom right-hand corner. Sometimes somebody can get this confused with a maple leaf, but the bark of this tree will always help you because it's the bark that's peely, and it can be olive, white, sort of calico with gray and brown. And you can see in the picture, this is the leaf that has stipules, and they look like little hula hoop skirts or poodle skirts that are surrounding the stem of the leaf or of the twig that the leaf comes out of. And then when the leaf comes off in the fall, the bottom end of the leaf is hollow, and the bud for next year's growth is what was underneath that stem as it pulled off. And a maple will not have a hollow stem at the bottom of the petiole. So those were the extras. Now we're getting into the compound leaves for alternate branching trees. And we're gonna do it by family again. So first we should start off with the peas, because they start off with the eastern redbud, which is not a compound leaf. Like, what's going on? So botanists, in their amusement, wisdom, I think it's a really like a gotcha that they like to play, because there is so we talk about leaflets and it being multi leaflet. When we get to the eastern redbud, they actually call it a unifoliate compound leaf, which means one leaflet compound leaf. Why? I don't know. And my grad school professor was a Fabaceae expert, and he would just giggle and walk away when I'd ask questions like that. He thought it was a riot, that I was annoyed by things that he and his cohort in crime would do. So most of the legumes are going to be compound leaves. There's a couple of other exceptions besides the redbud. If you're in a tropical place, there's a bauhinia as well, but we're gonna stay away from that. So the black locust is the one you guys are gonna see the most of. That picture is in from the right corner, but at the top of the screen. It's got a beautiful green rachis, which is the stem that goes out, with all those little leaflets that are actually on petioles, which are like petioles for the compound leaf. I'll try not to use too many of those crazy botany terms, but it has a two-pronged barb on that tree, so be careful if you get too close. And it has, this time of year, it's gonna start looking sort of a gray-green because there's a leaf miner that starts going crazy and eating a lot of its leaves as we get to the end of the summer. So it starts looking a little bit ratty, but a lot of people look at it as a bit of a trash tree, and I don't think it's getting a great rap for that. It's a great pioneer species. So if a farmer has left a field fallow, one of the first things you're going to see in there is you're going to see eastern red cedars, and you're going to see these black locusts. And these black locusts, because they're in the Fabaceae family or the pea family, they're fixing the nitrogen in the soil so that the next generation of trees has nitrogen for their growth. So they're really important in the successionary evolution of a field going from field use to back to woodland. And then we have the Kentucky coffee. That's on the red patio that I found. That's an amazing leaf to see. There's one nearby, and I happened to be leaf collecting in the vicinity, and I just couldn't help myself. And you'll see the specific epithet is dioecious, which means that there are separate trees for the male and female flowers of this. So it means it's not a monoecious plant, which would be one plant that has male and female on it. It's going to be like your holly, where you have one that has berries and you have in the winter and one that has none. So you have male versus female. And as a reminder, all of these have like that pea, like that long pea pod with the peas in it, which is why it's the Leguminaceae family. And then the last one is the mimosa or silk tree, albizia. This is going to be an invasive, which is why it has a little star next to it. And this is a twice compound leaf, just like the Kentucky coffee leaf. So if you look at the black locust leaf, that's once compound. But when you look at the albizia, it's compound and then it's compound again. So we call that bipinnately compound. I know, it's a lot of fun. Yes.
Okay, Keith is asking, the photo of the redbud, are all 6 leaves we see leaflets, or are they separate leaves?
Those are all separate individual leaves. I just thought it was really cool that they all look like they were stacked on top of each other. Rows of hearts, I thought was, so the one in the bottom with the rain on it, that's the one leaf that you're seeing from that picture. And I think that's it for the legumes. I'm going to swish over to the next family. So I think this is our last family. This is the walnut family. We have black walnut, and our picture of the black walnut is one in from the right, on the top, one in from the corner. That's the black walnut leaflet. And then next to that is the butternut compound leaf. And then we go from the walnut and the butternut into the hickories, because the hickories are all part of the walnut family. So bitternut hickory is the first hickory you see. And the way that we find and identify bitternut hickory, it has the same compound leaf as all the other hickories. But do you see that bright orange, yellow, sulfur colored bud at the end? That's classic. When you see that bud type or any sulfur yellow bud, you have got a bitternut hickory. You don't have to even know how many leaflets are in the compound leaf because you've already identified it. Mockernut, pignut, and shagbark are the three on the bottom. This is where life gets a little tougher to be able to tell these guys apart. Shagbark is pretty easy once you see the bark of the tree because it's shaggy. But for mockernut and pignut, I wanted to give you one more heads up on how to keep those separated. And I'm going to go one slide forward. Slide. Okay, there we go. So mockernut hickory is now Carya alba. I'm really disappointed about that, but I'm going to not be too mad or get into that much. But it was formerly Carya tomentosa. And if you look at the rachis between these leaflets on this leaf that I've gone zoomed in on, you can see that there's little tiny hairs all along that rachis. And those little hairs will be all the way down to the bud, all around the axial bud, all around the new growth on the stem. And when you look at a pignut hickory, it's Carya glabra. That means not a hair, devoid of hairs. If you see a hair, you are not looking at a pignut hickory. So this rachis is completely clean of hairs. The new growth bud and bottom of the stem is all going to be hairless. So this is where Latin really can help, because glabra means clear and smooth, whereas tomentose means hairy. So that is the official way to tell these two apart. And this is a great opportunity to use your hand lens to get some hand lens work in. And then I wanted to give you some words of warning, because there's a chance that you might be out there and you're trying to impress your friends, and we want to make sure that you don't do a bad job. So in this one, we have two different leaves, but they could easily be confused with one another. So the hint here is you've got to remember the branching pattern. So on the left-hand side, we have an ash. And on the right, we have a hickory. So that's going to be the first thing you have to do when you get to these compound leaves. Is it opposite or is it alternate? And your pignut hickory or your hickory over here is going to be alternate, and your ash is always going to be opposite. So that's your first warning. Your second one is we have the walnut on the right here, which is our Juglans nigra, and that's the black walnut. And then on the left, we have Ailanthus altissima. That is an invasive, I don't even know if I know the common name. Princess tree? No, that's Paulownia. Someone will tell me in the chat. But the Ailanthus has a little appendage that comes out on the leaf that has a gland on it. Oh, it's Tree of Heaven. Sorry, yeah. Someone just did a charade for me to get that. I'm really impressed. So the Ailanthus has a little bit of a appendage on the bottom part of the leaflet that has a gland on it. That's a really easy way to tell these apart. So just as that's my warning and heads up between those two. then my last one is for Carpinus, the ironwood, Carpe Diem, which is going to be on the left, versus Austraea, which is on the right. And that's got a shaggy bark that's sort of peeling and exfoliating. So I think the musclewood versus the hopthorn beam, I think those are always good to keep apart and separate. And then here are my references. I tried not to use too many things, but when I had to go find leaflet numbers, like I had to go find the real sources. So I had to go to those books. But for the most part, I tried to use the Virginia Department of Forestry 2020 Native Trees of Virginia book that we used as our dichotomous key throughout. And with that, I'll open up for questions. And I'll even find the chat box, I think.
Emily?
Yes.
This is Nora. There was a question, a comment rather, about the London plane tree when you were talking about the sycamore. Could you tell us about that?
Sure. So the London plane tree is a cross between the American sycamore and a European sycamore. And the difference is that the plane tree, when you look at it and the bark of it has a more olive color to it, where that on the American sycamore, it's going to be a stark white color on that bark. And there's a difference between the fruits that are hanging. So on the London plane, I think you have two hanging together, whereas on the American sycamore, you have fruits hanging singly. And I should verify that while I wait for the next question.
Yes, that is what DERS has.
Oh, good. I didn't make that up on the fly.
I will tell you that whenever we were looking at them on one of the tree walks, some trees had both 2 and 1, so you can't really figure it out that way.
Well, and I think that's fair, because if it's a cross between the two species, you're not always going to get the same ratio, and things are not always going to work out and be the same. So I think that's a fair assumption that when we have a cross between two species, there's going to be, just like when you have twins, one's going to have a different temperament than another, depending on recessive and dominant genes. So I think those things are probably typical. I don't know if I've seen London planes get into the wild. I think they've been pretty good about only being planted. I don't think they've had a lot of success moving out into the woods, because I don't think they have a great niche. The American sycamore is exactly where it wants to be, and it's going to suck up all the spaces that are for the American sycamore. And the London plane is going to be what we've made it into, which is a street tree that's widely used in all of the American cities, London, Paris. It's widely used around the world for that.
When we were in France, they were having trouble with the plane trees dying. The ones that were planted along the canals. Is that the same problem that sycamores are having in this country?
So the problem that they've talked about sycamores having recently is an anthracnose, I think. So I'd have to look into that some more, because I'm not sure I know enough about what's going on with the trees on the other side of the pond.
True. Sorry.
Oh, that's okay. I get pictures from people traveling all over the place for trees that they want me to identify. So it definitely is interesting because sometimes they don't tell me where they are when they send me a tree picture, and I'm like, are you in like a Central American country? Because that looks like a, and they're like, oh my gosh, you got it.
The French are taking the problem with their trees, the plane trees, there so seriously that they're in some places preemptorily cutting them down.
Oh,
It's awful.
that can be sad.
Yeah.
So Emily, I noticed you use the green and the white ash. Are you seeing ashes still in the wild whenever you are out there?
Yeah, I am. The black ashes have pretty much been decimated around here, but I have seen a fair good number of white as well as green ashes. I would say there are places where they're definitely being impacted, but there's also pockets where I don't see any evidence of the emerald ash borer.
And the other question I had is, I've seen Nisa a lot on your programs, but I have never seen the Tilia americana.
Yes, she's the new addition. She's number 2. She's the succession dog. But these are my 2 collectors. They head out in the wild with me to go and help me stomp around and identify trees. But they also like rolling and stuff that sometimes can be problematic.
Well, did anyone else have any questions? There was a comment on the chat about how impressed they are with your mnemonics and your physical actions. So you come across very well, even in the even on Zoom.
Excellent. Well, I'm glad. As my first attempt, it was interesting to try to. I learned all of my trees when they actually didn't have leaves. So sometimes I don't look as closely at leaves as I need to. So it was a really good exercise for me to be like, well, like, I don't even know if ashes have serrate leaflets or if they're entire versus a hickory. And so it was actually a good learning exercise for myself, because then I was like, well, how many leaflets are these things supposed to have? And then when I looked up for the leaflets of the ashes, I was like, well, I'm glad I never bothered learning this. Like, none of the books have the same numbers. So it kind of was, it was a good exercise for me. And hopefully by doing it by family, it made it a little bit easier to sort of take them in chunks rather than look at each tree individually. But I welcome feedback to, always improve. And as you know, Nora, I never give the exact same presentation twice in a row because I'm never satisfied. I like really changing it up and challenge myself to present the information in different ways. So,
well, thank you very much. We certainly appreciate it, and I hope someday that we'll be able to have you up here and do an in-person in-walk and everything. But thank you so much.
Thank you, and I always look forward to